Hi everyone. I'm gonna talk today about how to optimize active record query. Well, Gemma already introduced me, but I'm gonna make the same. I'm a software engineer working currently at Cloud Forecast.io. It's a little startup based on USA. I have almost 8 years working with Rails. It was a huge work for me. I'm ambassador of the program Women Tech Maker and Out Zero, and I'm organizer at the communities here in Peru, Ruby Peru, and TechTex Peru. And if you want to know a little bit more about me, you can go to my page, Kattya.Tech. Okay, so before start, why I did this talk? Some time ago, I worked in a project that I had to make a lot of reports. So many of these reports had to be on the dashboard page of the application that I was building. So I needed to optimize how to do these reports. At the beginning, I was doing a lot of queries, making a lot of joins, joining a lot of tables. So normally, our queries last a lot of time. So we started to search how to optimize. Then I'm gonna make I did a sample app that is a music app. I call it Spotify clone, and I had only those tables. First, I have the songs, artists, and albums table that are associated in a joint table called association. This table is not gonna have a model in Rails, so I'm not gonna use it. Then I have the ratings table only to rate, to have a rating of the songs and the albums, and a user that is who is going to rate the songs and albums. Here I have a polymorphic relationship that is how Rails help us to make a relationship between one to more than one table, in this case, two tables. So yeah, this is the database that I have in this sample. Then how I'm gonna know that the solution that I'm gonna show are really fast. I'm gonna measure in 3 ways. First, the elapsed time is how last every solution that I'm gonna show, then how much memory use every solution, and how many iterations per second is making every solution. To measure of these 2 ways, I'm using the benchmark model of Ruby and the GEMS benchmark IPS and benchmark memory. Okay, then let's start. The first report that I'm gonna build is the highest rating albums, the albums with the highest rating. This is the possible solution that I was thinking to do. First is a combination of the active record methods with Ruby methods, and then only using active record. Okay, I'm gonna explain the 2 solutions, but both solutions return the same result. Okay, that is 20 in my case. But what is the difference between them? First, let's analyze the first solution. The first solution in the first part is using the includes method. The includes method is gonna execute this SQL query. First, calling all the albums that we have in our database, and then calling all the ratings associated to that albums. Remember that we had an polymorphic relationship. So first, I'm making a filter here to only call the ratings that belongs to the table albums with the ID based on the old IDs that we had here. So here we are going to have as many IDs, as many albums we had. Okay, so the more albums that we had in our database, the more IDs that we had here in our query. Then The second part is I'm iterating over the result, the query result of the includes, then calling the ratings, all the ratings per album, and then calling the length method here to calculate how many ratings have every album. A note here is that I'm using the length method instead of the count, just to avoid to make another query here. So also I'm using the includes method here to don't do another query when I'm calling the rating method. And then after I have a long array of all the ratings per album, I'm calling the max method that is from the enumerators module, I think, in Ruby. Then the method calculate the max, the element with the max value inside the array. Okay, so that's the first solution. Then the second solution, if you see here, I'm using the method from that allows us to have a subquery inside here. So I'm explaining first the subquery. The subquery I'm doing here, I'm using first the select method of active record that allows us to select only the attributes that we want, but we could use it to add some calculations in SQL. So here I'm using count to count how many ratings have every album. Then I'm joining the albums table with the ratings to count the ratings and then group them by albums ID. So these three methods are executing this SQL query. Okay, so we are customizing what SQL query we want. Then I'm using the subquery to get the maximum rating counts. Remember that I put an alias here just to get the max rating code also inside SQL, not using Ruby. So let's compare the solutions. First, the elapsed time. Here, I'm comparing, I'm using the BM method from benchmark just to run 2 times every solution and to avoid that one of the solution be slower only for be the first in being executed. If we can see here, the first solution that we are doing lasts 5 seconds and the second one lasts less than 1 second. Okay. Then in terms of memory, we can see here the results of the comparison, and we can see here that the first solution is using almost 11,000 times more memory than the second solution. Okay. And in the iteration per second, in the comparison, we can see that here the first solution is slower 76 times than the second one. So here is what I just said. And if we can see here, what is the best solution between the two that I share here is the second one, that I'm using only SQL, only active record methods. So if we stop here, we can say that use only active record methods should be the best solution for every case. But let's see the second sample, the second report. Let's try to have the top 10 songs with their artists that have the highest rating. Okay, so I'm gonna add one table more to our reports. Then this is the first solution that I was thinking. First, call the ratings where belongs only those who belongs to the songs. I group by votable ID. I can make some calculations with active records, so I'm using the average method to have the average of votes for every rating. Then something that I noticed from active record methods is when we use the calculation methods, we don't get the normal structure from where or select methods. In this case, we have a special structure and only have the votable ID and the votable type. I mean the song ID and the rating. So here, after get the average of the rating per song, I'm sorting them by the second item, in this case, the rating, and then taking only the first n elements, in this case, the first 10 elements, and converting them because since here it's an array, I'm converting to a hash. Then I'm finding the songs because I want to build a hash like this. I need the title and the artist. So I'm finding the songs based on the keys of this result and including the artist, the songs with the artist. And finally, I'm doing the ratings. I'm iterating of the ratings to build the structure that I want to return as a result. But here first, I'm using the find method, but this is the find method of Ruby, not the find of active record. What I'm doing this is to avoid to make an additional query per iteration. So I'm basing that, but we know that we have all the data here, so I'm finding the song and just returning the structure that I want. Then the second solution, I tried to make using only active record methods. So here, because I want the top 10 songs, I'm doing over the stable songs. Then I'm including the artist because I need to return the response that I want. Joining with ratings because I need to calculate the average rating per song. Then making the calculation here using group to make the calculation well, then ordering or sort them by rating average, limiting to only get the first 10 songs, and then iterating over that. These 6 methods I'm giving me a query to get what I want. Okay. Then the third solution, because I have a one, is trying to use the two first solution, a mix of the two first solution. First, I'm iterating over ratings. I'm making a query over ratings to get the average of every song, then ordering to get the first 10 rating songs, then finding the songs that I got here and including the artist, and then making an iteration just to get the structure that I want. So let's compare this. If we can see here, the first one is the slower one, and the third one is the faster. It's a slightly different, but it's still the faster one. Then we have the how much memory use every solution. We can see here that using only active record is the one that use less memory, and the one that use more memory is the first one. And based on the iteration per second, you can see here that the slower one is the first solution. Okay, so if we can see here, trying to to compare all, to use all the measurements, we can see that the third solution is the first, the best one, just for this exercise. Then the last one, that is the final report. So here I'm gonna try to search the top end songs with the highest rating. It's the same one as the, I'm gonna use the same one as the last report, the second one. Then I write here the possible solution, because here I'm trying to get a part of the songs. We want the artists and the albums associated. So the first thing that I could think is that build a result only calling different methods based on the parameters. If we want the songs with the artists, we use a different method just to optimize that with Ruby and active record. And if we want the album, the songs with the albums, we use another. And if we want to use songs with album and artists, we use other parameter. And the second solution is using SQL and materialized views. But what are SQL and materialized views? The SQL views are virtual tables created normally from the select query that usually joins multiple tables. And each time that we call this select query, we are going to execute again that SQL statement. Okay, so in this case, I use Scenic, the gem Scenic, to make the sample, and to call, to use the view, only we have the model that represents the view, and we use the same active record methods over that. And then we have the materialized views that also are virtual tables, the same of the SQL views, but they store the query result of this virtual table. Normally, they are read-only and can be updated whenever you need them. So this is a cost additional that we have to think if we want to use this, because we are storing all the result of the queries instead of the SQL views that we are storing only the query. Okay, so I compared the solution. I used the best solution of the second report, and also added SQL view and materialized view. If we see here, the difference is very notable between the best solution and the new views solution. Then in terms of memory, we can see that SQL and materialized views are the same, and our previous solution is 174 times use this quantity more memory than the other ones. And in iteration per seconds, well, it's almost the same time, but the best solution that we did before is extremely slower. So what is the best things to do? Well, that's one thing that we need to make in every report. We have to analyze what is the problem and what to use. Then what is the conclusion? The first problem shows us how to use active records to make it more powerful using SQL queries. The second one shows us that it's okay to use Ruby to support active record methods. And the third one shows us that sometimes active records can also have a limit. So if we need to use SQL in some time. And one additional thing is, if you have to handle a considerable amount of data, try to get only the needed data. To do that, you can use the select and plug methods from active record. And sometimes the Ruby methods are better to iterate or to get a calculation than the active record ones. Don't be afraid to use SQL with active record. It's normal to do, and use size or length instead of counts, just to avoid to make an extra query and avoid the n+1 queries using includes methods. And that's it. Thanks.